So what we have done so far, we have plotted the variables and we're gonna go plot the regression lines now, the fitted model. So we have done with these variables, and during this break, I have just copy and paste my commands on our studio and make this graph also. Let me show you that this is the graph. I want to rerun it for you, so it will build up again. There is no harm actually, but you have taken some precautions for the rerunning if you are going to building or creating the variables. So it is actually come up with the lines, and if you want to zoom this plot, you can get a clear picture. This graph is actually between the biking and the heart door disease. Now we create the same graph for the rates of population within it. So for this data, it's actually giving you the smoking percentages between the heart disease and heart disease population and the biking percent of population and the smoking percent of population simultaneously by using this command. This is the zoom of the plot between the biking and the heart disease only. Now we going to plot another graph. So I'm just going to close it. The another graph which we going to plot is the percentages of the population of the three variables actually. So it's working on the rates of heart disease, biking, and smoking. And smoking populations are going to show in the color segments. So it's gonna build it here. See this graph in a clear picture. You can see, I hope that you can see it. Rates of heart disease of population as a function of biking to work and smoking. So we have taken the biking, the smoking, and the heart disease in number of percentage of population. These are the three uh, percentages for population. If you want to learn it as discussion, you can learn from here that what this graph shows. The percentages of the population in smoking 0.53, 15.44, and 29.95 respectively by heart disease percentage of population and biking to work percentage of population. If you want to plot the regression model in a graph, so you can also fit it in the same model. So this is the same graph, but you can see that an equation which you have find out by implying the multiple linear regression has been written here. So it is actually only the representations of the things, that 15 is the coefficient, minus 0.2 is the coefficient of the biking variable, 0.178 is the smoking variable, and it is for actually the heart dot disease variable. So I guess that it is the sum of the multiple linear regression class. You can also make these graphs for the linear regression. So just go and try it, and try also it for the other data sets. So it is very convenient for you for this. So in the last of the discussion, there is rewritten actually the results of the data sets, which are the same data sets that in our survey, that there are 500 towns, and we found significant relationship between the frequency of biking to work and frequency of heart disease. The frequency of smoking and heart disease is reported as a p-value very small, which is less than 0. And specifically, we found 0.2% decrease, which is used by the negative sign, and in the frequency of the heart disease for every 1% in biking, and an increase by 0.178% increase by choosing the positive sign for the estimate variable which we have found in the model. So these are the repetitive things, I guess, that you have done with it. So see you in the next class. I'm going to end this class. Just investigate more and more models for your practice, R Studio.